All right, thank you, Chris, for the introduction. Yes, I'm Cedric Justin, a research faculty at Georgia Tech, and I will be presenting this morning some of the insights we learned from doing research with some of our students at Georgia Tech about the retirement of 50-seat regional jet. So what is it that we're talking about when we talk about 50-seat regional jet? Well, we're talking Bombardier CRJ 100, 200, Embraer 140, 145, and the new one in town, the CRJ 550. We've got about 400, give or take, of those currently flying in the US, and the average fleet is between 20 and 22 years old. What it means is retirement will happen pretty soon. So speaking of retirement, if we look into the past to get some insight into what the future may hold, we're looking here at the retirement of CRJ 200 expressed in terms of flight hours and flight cycles. What we can see is that most of them are retired by the time they reach 40,000 flight cycles, or about 50,000 flight hours. If we move on to the Embraer 145, we see the same kind of picture. The Embraer is a bit younger, so if you look at the distribution, it feels a bit truncated because probably most of them, a small chunk, I would say, of the fleet has just been retired. But what we see here is we see peak of retirement at 32,000 cycle and 42,000 cycle, which basically is in line with when those aircraft needs to go into heavy maintenance for the airframe. But basically the same conclusion hold. By the time they reach 45,000 cycle, most of them will be retired. So having those retirement timeline in mind, let's look at the current fleet that is currently operating in the US, and using the utilization, the current utilization in terms of flight cycle and flight hours, let's see when we can expect those to be retired. So here you've got a graph that depicts the time at which the existing fleet will likely be retired. And what you see here is by the mid-2030s, most of the fleet of CRJ 200 here is probably going to be retired. And if you go to the Embraer 145, you see the same kind of story here. By the mid-2030s, you will have most of them retired. Embraer tends to be a bit younger, but they tend to be used a bit more aggressively. So basically the timeline kind of match. So what does it mean in practice? It means that most of the RJ50 fleet is going to be retired within the next 10 years. And if I look at the fleet and how the fleet will shrink over time, that's the kind of graph that we're now. We see that it's going to shrink fast. And what's a bit concerning, and I would say a bit unusual in aviation, is that there is no replacement inside for those RJ50s. So what does it mean in practice if you retire them and there's no replacement? Either you have to down gauge, and if you down gauge, you go to smaller aircraft, most likely 9-pax aircraft, that are not cabin type of aircraft. So the passenger experience is very different. Or you have to up gauge, in which case you go to RJ70, in which case you might have to lower your flight frequencies because you need to fill up those aircraft. Or you will have to discontinue services if you cannot fill those aircraft. So we have had also a newcomer in town over the last 10 years. It's the CRJ 550. It was kind of motivated by the scope clause you have at most major airlines in the US, which tends to favor the use of 76 aircraft instead of 70-seat aircraft. What was the outcome of that is a had fleet of 70-seat aircraft that they decided they could reconfigure into 50-seater aircraft, having a more spacious cabin with premium product, with economy plus and business class seating. Passenger love it. Passenger wants to have those higher, those better flying experience. Airlines love it because it helps them increase yields and revenue if they can fill them up. But it's not necessarily solving all of our problems, because those CRJ 550 are actually CRJ 700 that have been reconfigured, and the feedstock of RJ70 is not only limited in size, but it's also not exactly new. We're speaking of CRJ700s that are probably midlife or second half of their lives, economic lives. And we don't have that many of them that are available for conversion. So we have to think about it more as an interim solution. And in that case, it's probably going to delay the retirement of 50-seater by probably about 5 years. So the aggregate effect of introducing the CRJ550 is kind of limited, right? It's going to be most likely used at United and Delta. American Airlines has kind of different scope close considerations. And at the same time, we've got a limited feedstock, right? So we need to investigate other scenarios, what could happen for those markets that have currently by 50-seat aircraft. So having talked about actually, I do have a map here. Having talked about the retirement of those aircraft, let's look a bit about how they're being used. This is a map depicting all the routes that are flown by 50-seat aircraft in 2024, I think, with at least one daily frequency. So we see that they're basically flying everywhere across the country. If you retire them, you will feel the impact everywhere. Now, what we decided to focus on is on those routes that may not be able to be upgauged to 70-seat aircraft. So how did we do that? We looked at the frequency on each of those routes. We looked at the number of passengers that were carried to figure out if you were to upgauge, could you actually maintain a given load factor? In that case, we use 65%, we could have used another number. To figure out which routes are actually at risk of being discontinued. But more importantly than routes that are at risk of being discontinued, we looked at actually airports that are served exclusively by those routes that are at risk of being discontinued. Translation, those airports might be losing all of their air services, commercial scheduled air services, when those RJ50s are retired. That's the map of those airports that are at risk. We've got 33 of them. That's about 10%, give or take, of all the airports in the US that receive commercial air services, scheduled air services. They're spread over the entire country, and we have to notice that a few of them are actually receiving subsidies through the Essential Air Service program. So it's debatable whether services at those airports will be entirely discontinued. They might be moved on to 9-pax aircraft. Regardless, that's what we have to play with. Now, having identified which of those airports and which of those communities might be losing air services, we decided to try to analyze whether some of those people that are going to be impacted can be recaptured at other nearby airports. So the idea here is you're losing service at one airport, you might go to a nearby airport and catch another flight. And maybe it's net zero for the regional airline operating those flights. So in order to do that, we need to understand the behavior of travelers. And in order to understand the behavior of travelers, we decided to rely on an extensive survey of mobile devices that was collected in the United States, about 80 million devices, to figure out how people travel, how people move, where they start, where they end. Now that's very much a game-changing type of analysis that was not possible 10 or 15 years ago. That's because all of you have phone devices and Big Brother is watching you day and night. They know everything about you. So we're able to get the street number, if you will, of where people start their journey, where they're going, how much time they spend moving, and what kind of mode of transportation they used. In turn, that helps us not only create those catchment areas around the airport, so basically statistical areas where most of the passengers are coming from when they take an aircraft or a flight from a given airport, but also it will help us calibrate a mode choice model, which I will explain in the next slide. So what is a mode choice model? It's a model that tries to explain how passengers are making the decision when they're facing multiple transportation options. So maybe they can drive, maybe they can fly, how do they make those decisions between flying and driving? So we use a pretty simple mode choice model. It's not meant to explain everything. It's trading travel time saving and cash expenditure on the journey to figure out how people make the decision. How are we going to use it? Well, when routes are going to be discontinued, we're going to use it to figure out whether those people will be flying from a nearby airport or will be driving instead. And in that case, regional airline would have lost those passengers. So let me show how it works in practice with a use case or a selected few examples that I have. I have this route among those 33 airports that are at risk between Liberal and Denver. It's flown by CRJ200 by United Express. We've got the catchment area for Denver and for Liberal in Kansas. This airport is at risk, so we might be losing this air service. So if we do those passengers in Liberals, I might be looking at other options nearby. So the closest option is actually in Dodge City, which is also in Kansas. It's not too far away, as you can see here, it's just nearby. Problem, this airport is also at risk of losing RJ50 service. Not cool, we're not solving the problem. So we try to extend a bit the radius as to what airports are available. The next closest airport is actually Wichita, Kansas, which is about 3-hour drive from Liberal. The advantage of Wichita, much larger airport, many more services that are available. Now, let's first look at those origin and destination passengers. So if we are driving from Liberal to Denver, that's basically the distribution of travel time that you would have between the catchment area at both of those airports. So you would be driving between, give or take, 4 and 8 hours. If you're flying, as you do currently on United Express, that's basically the distribution of travel time. You're basically saving about 50 minutes, 48 minutes of travel time. Now, OND is just a very minor fraction of the passengers that are on board the aircraft, less than 5%. Now, those 5% passengers, if they lose their air service to Liberal, they're going to fly from Dodge City. That's what the travel time looks like. Less good. So we're just saving about 25 minutes, which means that we will be losing some passenger to driving. And obviously, if we're going all the way to Wichita, the situation is even worse because the drive time, if you go and fly through via Wichita, is actually longer than if you were driving directly to Denver. So here you're probably going to lose most of your OND passengers. As a matter of fact, for this example, we're losing 85% of our OND passengers. So those are ONDs. It's a tiny fraction in your RJ50. Most of the people flying those RJ50s are typically connecting at a hub to another destination in the US. So I picked the largest market out of Liberal, which is actually Las Vegas. So, and I'm looking at just the first segment denoted by 1 on this graph, right? So the drive time, if you were driving from Liberal to Denver and then flying to your final destination, the journey time would look like what we have in gray. If you're flying from Liberal to Denver, as you do right now, your journey time will be this blue histogram, a distribution. So again, you're saving quite a bit of time. If you're flying from Dodge City, you're saving a bit less time, but it's still beneficial to fly. That's what we're seeing here. And if you're flying through Wichita, actually it's not as bad as it was one slide ago, because now you've got non-stop flight from Wichita to Las Vegas. So you won't be losing all of your passengers if you have to go through Wichita. Problem for regional airline, this service is on a 737 operated by Southwest. So you're gonna lose this passenger anyhow. So that was a specific set of examples. Let's now look on average. When I look at those 33 airports that I have in the US, what is the travel time difference when I lose those services? So you have this distribution here that highlights two things. First, the average travel time is increased by 73 minutes on average, but it's very diverse. It really depends on the set of airports that you have, what are the neighboring airport, what is the road infrastructure to go to this airport, and so forth and so on. We have some where the journey time is going to be increased by almost 3 hours, got some where it just increased by 10 minutes. So again, very diverse, but on average, you've got significant travel time increase for most of your passengers. So that's going to be inconvenient for them. And as you will see, we're going to be losing some of those passengers. So here you have a histogram that depicts, actually let me go back, there's two of them. Yes, we've got a histogram that depicts how many passenger, in that case OND passenger, you would be losing when you lose those air services and you have to reroute via another airport. On average, you're going to be losing 36% of your OND passengers, but you can see here that there are many markets where you're losing more than 75% of your OND passengers. Now, as I said before, it's a tiny fraction of the entirety of the passengers that you have on board, but it's probably also those that are the most profitable because those are the highest yielding passengers. If I move on to both OND and connecting passengers, that's what I have in this bar chart, we see that we're, on average, losing about 8% of our passengers when we remove those air services. And the annual loss of passenger, it's about, on average, 2,500 per month. So it doesn't seem too large, right, 8%, but at the same time, it kind of tends to snowball, right? Because when you start losing your services, the attractivity of the community kind of goes down, right? And there's kind of a snowball effect where you're going to be losing some of those businesses. And if you lose those businesses, you lose some business trips and you lose passenger, right? So forth and so on. So I would say those are very conservative estimates of what you would expect to see when you remove those RJ50 services at those 33 airports. So what have we seen so far? Or what have we learned? We have learned that the RJ50 are going to be retiring pretty soon, within the next decade. There's nothing in line to replace them. The RJ550 is an excellent aircraft, but it's just delaying the retirement by about 5 years. So it's not a long-term solution. So we need to look at other scenarios. And when we look at those other scenarios, which mean changing the routing of those passengers, then we see that there are 33 airports that are at risk of losing all commercial scheduled air services, about 10% of the airport in the US. And that translates for those communities impacted by an increase in travel time of 73 minutes, which is quite significant, and a reduction in your passenger volume of about 8% on average. Again, depend on route to route. That's why we have to do those route-to-route analysis like we do with those GPS data sets. You can't just do an average, it doesn't work. It really depends on the geography, how close are the neighboring airport, what kind of road networks you have, and so forth and so on. That basically summarizes our key finding on the retirement of 50